Let's move on to example 4. A bag contains 50 marbles. You randomly draw a marble from the bag, record its color, and then replace it. The table shows the draw after 30 draws. Predict the number of red marbles in the bag. So this one, we're wanting to use our past results from our experiment to make a prediction of how many marbles are in the bag. So first, we need to figure out what is our relative frequency, what is the likelihood or the probability that we rolled or that we got a red marble out of the bag. So our probability of getting a red marble out of the bag based on the experiment, well, there were 9 red marbles that we got out of a total of 30 times drawing from the bag. So we got a proportion of 3 out of 10 marbles drawing from the bag. You could write this as a decimal too. If you wrote it as a decimal, let me do a real quick calculation here. Oh, I didn't need a calculator for that, but it'd be 0.3. So out of our 30 draws from the bag, 30% of the time we got a red marble. Now, if we know that the bag contains 50 marbles, 30% of those marbles are approximately going to be red because 30% of the time we drew a red marble based upon our experiment. What that means for us is to find how many red marbles are in the bag. We are going to take our number from the experimental probability, 0.3 or 30%, and we're going to multiply that by the total number of marbles in the bag. So 30% or 0.3 times 50 is going to give us 15. So that means there are about 15 red marbles in the bag. So what we did is we first found the experimental probability of getting a red marble based upon the table of results. We took that number and multiplied it by the total number of marbles in the bag to figure out about how many of them are red. I want you to use this same concept to work through the next example where it says practice using experimental probability. Take a moment, pause the video, see if you can get it, press play to see the answer. All right, so you should have paused the video and worked on this problem. It says an inspector randomly selects 200 pairs of jeans and finds 5 of them defective. About how many pairs of jeans do you expect to be defective in a shipment of 5,000? So first we need to figure out, well, out of the information they're giving us in that first sentence, what's the probability of getting a defective pair of jeans? Well, they said that out of the 200 that they selected, 5 were defective. So that means the probability of getting a pair of jeans out of the 200 being defective is 0.025 when you do 5 divided by 200. So now, to figure out and make a prediction on a larger scale, we're going to take this decimal and multiply that by the larger number. So we're going to take this number of 0.025, multiply it by the 5,000 to figure out what would we predict to be the number of defective genes out of 5,000 if we know that there was a 0.025 chance of getting defective genes out of 200. So we multiply this by 5,000 and we get 125. So now we would write a sentence that says there are about 125 pairs of genes that are defective out of the 5,000. All right, let's do our very last example with modeling real life. The theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6. The wheel has 18 sections. It says how many sections have a bobblehead? Well, we know, and let me zoom this out a bit so you can still see it. There we go. So we know, according to this setup, that 1/6 of the wheel is bobbleheads. And if it has 18 sections, we got to figure out, well, what is 1/6 of 18? The word of means we're going to multiply. So we're going to take that fraction of what is a bobblehead and multiply it by the total number of spaces we have on the wheel, which is 18. That's going to give us 3. So we know that there are 3 sections on the wheel with a bobblehead. Now it says, okay, well, let's make a prediction. We know 1/6 of the wheel is bobbleheads. We're going to spin the wheel 540 times. So, how many bobbleheads do you think we're going to win if 1/6 of that wheel is bobbleheads? Well, it's going to be the exact same thing. We're going to take 1/6 times this larger number of 540, because that is the proportion, or the percent, if you will. I know it's not written as a percent, but you could write this fraction as a percent of times that you're going to get a bobblehead. So that times 140 gives us 90. So we can predict about 90 bobbleheads will be won out of 540 spins. Right, so that's the end of the experimental and theoretical probability. I'm not expecting you to feel 100% confident on this. Some of this stuff can be really hard, and that's okay. If you're struggling, please ask me questions. Begin working on the homework. If you're still struggling and you're wanting some immediate feedback versus emailing me or something like that, you might want to try videos on maybe Khan Academy or YouTube. Just searching experimental probability or theoretical probability would be a helpful tool as well for just some more immediate resources. All right, I hope you enjoyed this video. You're now good to move on to the homework, and have a great day.